Hi, my name is Peter Johanni, and my project is balancing a fork and a spoon on a toothpick. What you'll need is a fork, a spoon, a toothpick match, or I used a bamboo skewer, and a cup. Pause here and try and balance them yourself, and then return when you are done and you can see how I did it. So this problem is all about balance in the center of mass. The center of mass is the average position of the mass in an object, and is most easily found by finding the balance point of the object, unless it is not on the object. The center of mass can be used to model an object as a single point, and as said previously, can even not be on the object itself, which is what you will see in this problem. The blue dot represents the center of mass for the spoon, and the red dot represents the center of mass for the fork. The weight of the spoon and fork are not equal, so the center of mass is not exactly in the midpoint, but rather slightly skewed towards the heavier one, in this case the fork. The forces are balanced on either side of the toothpick. The white dot is covering the toothpick because it represents the center of mass when looking from the side, and since the fork-spoon system is balanced on the toothpick, the center of mass is the toothpick. Looking from the top-down view, we can see that the center of mass on the fork and spoon are in fact not actually points on either object. The white line that connects the two dots of the center of masses holds the center of mass for the fork, spoon, toothpick system. The center of mass is aligned directly over the edge of the cup, which is why it is staying up, because the system can be modeled as a single point at the center of mass, so it is just a force directly downward on the edge of the cup. Also, just as a side note, you can burn the toothpick from the part that is inside the cup, and the system will not fall because the glass and insulator will absorb the heat energy, putting out the flame, and the mass of the burned toothpick is so small that the amount that it moves the center of mass is negligible compared to the thickness of the cup. Some common misconceptions are that the center of mass has to be on the object, but in fact it does not, as we see in this problem, and that even though all the forces are being applied through the toothpick to the cup to support it up, most people would believe that that would cause the toothpick to twist out and fall, but because the center of mass is really the point at which it can be modeled, and that's really the thing that matters in this case, since that is over the cup, it does not matter that all the forces and the way that is being applied through the toothpick.